Hello, class. Today is the 11th of March. And what we're going to be doing is we're going to be going straight into the next lesson. Lesson 6 of our 7th grade, Module 2. Now, what we're going to be doing today is we're going to be working on distance. Now, distance is going to be, as I'm sure you can tell, pretty related to our addition and our subtraction, but our way of finding it's just going to be a little bit different. This video should be done pretty quickly though. So what we're going to be doing is we're going to skip straight down to example 1, and we're going to look at the formula for finding distance between two rational numbers. Now you might be asking yourself, well, why are we skipping so much in this lesson? It's because we've actually already gone over how to find distance in the first place. We already did this, if you remember last module when we were working on our coordinate plane, we had found out how to find the distance between points on a coordinate plane. This is going to basically be the exact same as that. So for this, it's asking us to find the distance between -3 and 2. So step 1, hey, start on one of our endpoints. So we're going to start on -3 and just count the number of units from this endpoint to the other endpoint. Okay, well, my other endpoint's 2, so 1, 2, 3, 4, 5. Well, that was easy. That means my distance 5. Well, let's make sure that it's the same if I start on my other endpoint. It should be, but let's just make 100% certain. 1, 2, 3, 4, 5. Look at that. It's still going to be a distance of 5 away. Now, what we're going to do is we're going to actually be using a bit of a formula here. Now, hopefully you noticed that we passed by our 0 over here. We've passed our point 0 right in the center here. So, if I think of distance when it comes to our number 0, I normally think of something, and hopefully we should remember, called absolute value. When I'm using my absolute value, we're actually not just going to put one number on the middle of our absolute value here. We're actually going to put 2, and we're going to do it in sort of a subtraction problem. I'm going to have -3 minus 2. Our formula is going to take our first endpoint and subtract our second endpoint. Now, looking at this, hopefully you can remember that if I'm subtracting something, I can just change that to addition. So let's do that. Sorry about the interruption. Let's do that. I'm going to keep my first number. My second number, well, first, before we even get to that second number, my subtraction becomes addition. And then I'm talking about the opposite of my second number. So I've got -3 plus -2. Well, what is -3 plus -2? Well, it's -5. So I need to find the absolute value of -5. The absolute value of -5 is +5, just like what we had up there. Now, that works for when my starting point is -3 and my ending point is 2. What if my starting point was 2 and my ending point was -3? Well, let's see if it works the other way around. I'm going to start at 2, and I'm going to subtract my end point of -3. And remember, I'm taking the absolute value of this. Well, once again, I'm going to use my subtraction rule, so I've got the absolute value of 2. Subtraction becomes addition, and then I take the opposite of my second number. The opposite of -3 is +3. So now I have 2 plus 3 So that's going to be equal to 5. And then the absolute value of 5, that's 5. So, phrase it down here, for two rational numbers, p and q, the distance between p and q is the absolute value of p minus q. So, whenever I have two numbers, if I want to find the distance between them, I take the absolute value of the difference of those two numbers. Now, let's go through, we're going to do example 2 together, and then I'm going to leave the rest of this to you guys. For example 2, it's making a distinction between a change in elevation and distance. Distance is always going to be positive because distance is either like 5 to the right or 5 to the left, but it doesn't matter which direction I'm going, my distance is always going to be positive. However, change in elevation and change in temperature, they can be positive or negative depending on whether you're increasing or decreasing, if you're going up or going down. Okay. So let's look at this example and we'll see the differences between distance and elevation. We start with a hiker who's going to start hiking at the beginning of a trail at a point which is 200 feet below sea level. And he's going to hike to a location on the trail that is 580 feet above sea level, and he's going to stop for lunch. It's asking us what's the vertical distance between 200 feet below sea level and 580 feet above sea level. Well, first things first, we need to take our integers. 200 feet below sea level, that below means that this is going to be a negative 200. 580 feet above sea level, this means that this is going to be a positive 580. So now to find distance, remember our distance is going to be the absolute value of our starting point minus our ending point. Now, once again, my subtraction rule says, let's get rid of subtraction, make it addition. So I've got my negative 200. Instead of minus, it's going to be plus. And now I take the opposite of my second number. So instead of positive 580, it's going to be negative 580. What is negative 200 plus negative 580? Well, that's going to be negative 780. And then the absolute value of that is going to be positive 780. So the vertical distance is going to be 780 feet. How should we interpret that 780 feet? The distance is 780. Is the change in elevation going to be positive or negative? Well, seeing as he started below sea level and went above sea level, he went up 780 feet. The second half, though, it says that after lunch, the hiker hiked back down the trail from the point of elevation that he was at, which was, as we remember, 580 feet above sea level, back down to the beginning of the trail, which was 200 feet below sea level. So On his first trip, he went up. This time he's going back down. But once again, since it's asking for our vertical distance, even though we're going down, our answer is still going to be positive. Distance is always going to be positive. And we can prove that we have absolute value. Our starting point at this point is going to be 580 minus our ending point, 200 feet below, is going to be negative 200. Remember, however, our subtraction rule says get rid of that minus and get the opposite of our second number. So our first number stays the same, 580. Change to plus. The opposite of negative 200 is going to be positive 200. $580 plus 200, that's going to be 780. Which means the absolute value of 780 is going to be 780. So the distance, it's the same distance. Whether we're going up the trail or down the trail, the distance that our elevation is changing is the same. The distance is going to be the same. But our change in elevation this time is going downwards. So even though the distance remains positive, our change in elevation, we went down 780 feet. So instead of going up 780 feet, our elevation is going down 780 feet. Now, again, we've had practice with distance in the past, so I don't feel as though I need to continue on with this. Instead, what I'm going to give you guys is you guys are going to work on exercise 3 and 4 on your own. That is going to be your work for today's class. As per usual, if anyone has any questions, make sure to send me a message on Schoology and I'll help out as best I can. Other than that, I hope you guys all have yourselves a great rest of your day. I'll either have another video up tomorrow or I'll inform you if I won't. In any case, have a great rest of your day.